Hello students, before going deep into the topic of AC generator and DC generator or electric motor like that, there are few things are there that you have to know. Okay, like magnets are there, properties of magnets. Okay, and what is compass? Okay, horseshoe magnet. Okay, these are very important. Okay. Clear? And these small strips which are there I have used as a magnetic field lines, right? Magnetic field lines. And this one armature. Okay, armature coil, armature. Clear? This one is the armature here. So these are the few things here. Properties, I think everybody knows about the properties. Clear? About the magnet, everybody knows the property here. Okay, north, south. Okay, what are the properties of magnet here? If the like poles, okay, what are the like poles here? Like poles repel each other. South pole repel each other. Okay, and unlike poles attract each other. Clear? This is the first property of a magnet here. Clear? And always remember that we can't see the lines, magnetic lines, isn't it here? We can't see the magnetic lines here, isn't it? Then also see the movement of this. Okay, nothing is there in the middle here. Nothing is there. Clear? Nothing is there in the middle. But then also this magnet is moving now. See it is moving without any contact. See, it is moving then. Clear? What makes it to move here now? The field, magnetic flux. Okay, lines have that much power. Okay, to push it back. See how it is moving out. Clear? See here. Clear? See here. Okay, so like the same thing, compass also we can show it. Okay, one diagram is there in your book, magnetic field lines. Okay, magnetic coming from north to south. Okay, north to south, some lines they have drawn, isn't it? So with the help of this compass we can draw the lines. Easily we can draw the lines here. Okay, this is the needle. This is the needle here now. Now movement of this needle is called as the deflections. What they call as here? Deflections. Now I'll show the deflections here. See the deflections. If I bring the south pole here now, see here, the power of the magnet, the field lines. The field lines are moving here. The field lines are moving from here and here. Everywhere the field lines are moving. Now see, when I take this bar magnet near to the compass here, see the needle here now. It have too much power now. Okay, magnetic flux and magnetic field lines are many are there entering into this compass here. Many are there. If I take here long, okay, distance here now. If I show the long distance here now, very little power, very little power. But it is moving here now. See, up to from here to here, it have the magnetic line power. See, it's moving then, still moving. Clear? Now if I take here now, still here is no chance now. That means from where the needle is moving here, this complete is called as a magnetic field. Clear? If I bring here now, it is a magnetic field. This all area is called as a magnetic field. Clear? Now if I change the direction, then the needle also will change. See, the needle also will change. See, the needle also is changed here. Clear? The changing of this needle, you can make a graph then. You can make a graph starting from south. So keep here. Okay, keep one point here now. After that point you make it move. Okay, along with that, what happens? You have to move this one. Okay, continuously if you move here, this needle also will move. A time comes, it will come and join here. Okay, this position. Clear? See? Clear? Clear? From north it is starting here now. From north direction, from the north, the magnetic field lines are coming out. Clear? From the north, this direction, from the north it is coming out. See the needle here, red color one. See the needle, how it is changing here now. Slowly it's entering into the south. Got it here now? So the magnetic field lines coming from north to south. From here also same thing, and here also the same thing. From the north starts. Okay, now from where they enter in? South. So magnetic externally from north to south, the magnetic field lines are entering. From south to north, from internally they are entering here. Okay, internally. Okay, from south to north. Clear? From internally in the south to north, the lines enter here. Then once again from north to south. See you can see clearly here how the lines. With this we can draw the diagram. The movement of the needle. The movement of the needle. See, this happening only because of the magnetic flux, magnetic lines. Clear? And next one is about the what in that experiment, AC and DC experiment. I have prepared the armature. This is the armature I have prepared. Okay, rotation of this armature coil, rotation, heavy rotation of this armature. That means why they are rotating it here? Too much. Why the rotations are going on here now? Because we are giving the mechanical energy to it. Mechanical energy produced by using the fuel, petrol, diesel. We are using in the generator, and we're on the generator. Then start. Okay, how much fast it moves here now? The electricity is produced. Okay, here the electricity produced. Clear? Mechanical energy convert into electrical energy. Clear? This is the armature. So these are the lines. These are the magnetic field lines. This is the magnetic field lines. I have taken only 3 here. Initially it will be 0. In the video I explained you, isn't it? Initially it will be 0. Okay, but later with the help of a Fleming's right hand rule, isn't it here? Force, current, magnitude. Clear? Force, current, and the movement. Okay, from magnetic flux moving from north to south. North this side and south this side. Okay, the moving of lines. So this lines, movement of these lines here, then slowly what up in the rotation of this armature. Then here 2, here 1, it enters. A time comes 0, initial to maximum. All the lines enters. When it is maximum vertical position, all the lines enters here. So this quarter here, 1/4. Once again it moves half direction. Again what happened? 0 initial here. Half rotation is completed here now. 0 to maximum, isn't it? Once again 0 to maximum. Whole one rotation is completed. Total lines are getting clear. So like that, total rotations would happen. Many rotations take place here to produce the electric energy. Clear? This is the armature. Clear? This is called the armature. So check this carefully, this one first, and then here this horseshoe magnet. Okay, this magnet is called as a horseshoe magnet. This magnet we have taken for the experiment of AC and DC generators, isn't it? This is a very small, but you take a big one, big powerful magnet we have to take. Okay, horseshoe magnet, that too, this curved surface. It should have the curved surface. If you see like this, it is a curved one. But if we see like this here now, see it is looking like a ball. Right? It's looking like a ball. It looks like a curve like this. But if you turn it like this, it is a ball. All the races come here. Clear? Look like a ball here. Clear? So it is a curved surface. And heavy powerful magnet we have to take for this experiment. Clear? In that I have written what the requirements needed to prepare the AC and DC generators. And there specially horseshoe magnets are there. Armature is there. Okay, slip rings are there. We have taken the 2 slip rings also in that, isn't it? See this. You can understand and see here. Okay, 2 slip rings are here. Okay, here's the horseshoe magnet. Clear? Like this only you have to keep here one and here one. South pole, north pole. Okay, here south pole, north pole, both they are given, but actually that magnet will be totally different. Okay, bigger one, high powerful one. Okay, curve will be there here. Inside it will be totally filled. Okay, so only curve will be there. Only curve, just like a ball. Okay, ball. Clear? So like that, here one we have to keep magnet, and here also we have to keep one magnet. Clear? And in the middle, what we have to keep here? Armature. Here we are keeping the magnets. 2 magnets we are keeping here. Clear? And here we are keeping the armature. And for this armature, we are giving the name A, B, C, D. Corners of this armature. 1, 2, 3, 4. So A, B, C, D. Clear? And this armature is entering here. No, see, it's entering. That armature, one of the wire is connecting with the to S2 and S1. Clear? See here. This is a direct current here. So we have the commutators here now. Commutators are nothing but S1, S2 is called as commutators. Slip rings. They are called as the commutators here. Clear? Clear? Brushes will never change in this. Okay, these are the carbon brushes. These brushes. These are the brushes. They are the common. They will not move here. But only slip rings can move. Clear? Hope everybody have understood. Like, share and subscribe my channel. Okay? Thank you. I'll send the notes also. Okay, don't worry. Notes also I'll send. In this video, I'll show you the magnetic field lines. Okay, I think in school also you have seen that, but I'll show you. These are magnetic field lines. Okay, practical, I'll show you how the really magnetic field lines looks like. Okay, by taking the iron fillings. I have taken the magnet. Okay, so North Pole magnet is here, and I have taken the plastic cover, and these are the iron fillings. These are the iron fillings. Okay, I hope everybody knows what the iron fillings means here. Okay, so these iron fillings, disturb the iron fillings. Okay, now we can see the magnetic fields clearly. Okay, so shall we start? A small experiment, but you can see this one clear. Can you see? See how much clearly the magnetic lines fields are forming here now? See? Clear? Okay, students, today I'll explain you about AC generator. Okay, this is the sketch of AC generator. This is in the lesson of electromagnetism. Clear? These 2 or 3 topics are very important from that lesson. AC generator, DC generator, electric motor. Okay, these are the important questions from that. So I'll explain you this completely sketch here, how this AC generator prepared. Okay, how we can prepare in the lab. Okay, this is a sketch of that. Clear? So what is actually AC generator? Main principle of AC generator here now. Okay, it generate. Okay, this main principle of generators, okay, is to convert the mechanical energy to electrical energy. This is the main one. Okay, the main work of AC or the DC generators is to convert the mechanical energy into electrical energy. So to get the mechanical energy, we will use the fuel like petrol is there, diesel is there. Okay, that we'll use here. Okay, when the current puts off, okay, when the current goes, electricity cut off, at that time we use the generators in malls, hospitals, houses. We use the inverter generators, isn't it here? So in that inverter, anyhow, it is used by the battery. Okay, just look like a generator only here, but in generator fuels are used. Okay, fuel like petrol, diesel is used here. Anyhow, this mechanical energy is generated with the fuels like a petrol, diesel. Okay, to convert the mechanical energy into electrical energy. Then the produced electrical energy or the electrical energy is produced here now. It functions. It helps to function the electrical appliances in home, shops, hospital, malls, big malls like that here. Many electrical appliances are there. Like fan is there, lamp are there, TVs are there, bulbs are there. These are all the electrical appliances. Clear? Now, what is the requirement to prepare it? Okay, some requirement should be there to prepare the generator, this AC generator. What the AC generator means, alternating current generator. Why it is called so? Okay, I'll explain. The last we'll learn that. Okay, why it is called alternating current generator. So we need some requirements here to prepare the AC generator. Okay, so what are the requirement we need here now? The first one, what we need here is 2 horseshoe magnet. Horseshoe magnets. Okay, it should be curved surface. Curved surface. Curved surface. Okay, and the second one, we have to take one rectangular. Okay, one rectangular armature. One rectangular armature. Clear? And that armature we can give name also. Okay, A, B, C, D. I'll show you what the armature means. Coil. Nothing but a coil. And the third one, we have to take 2 slip rings. 2 slip rings. 2 slip rings. And there also we can name it S1 and S2. Clear? And fourth one, we have to take 2 carbon brushes. 2 carbon brushes. 2 carbon brushes, and for this also we can give names B1 and B2. And the fifth one, any electrical appliance you can take. One bulb you can take here. Bulb. Okay, here it is in this experiment is called as the load. Okay, clear? These are the requirements. Okay, these are the requirements here to prepare a AC generator. Clear? These are all the requirements here. Now this is the sketch. Okay, how to prepare it here. Just now I told armature, isn't it? Like, what is the armature? You know, this coil. Okay, this one. This is the armature. This one is the armature. Okay, two magnets I told. Okay, horseshoe magnet, curved surface. This is the curved surface. Curve. Okay, north pole, south pole. Clear? Two magnets. One armature is there. Okay, this is the armature what I prepared here. So this is the armature which can rotate easily. Okay, coil which can rotate. This is the armature. Clear? This is armature. For this armature we are given the name A, B, C, D. This side A, B and this side C, D. Okay, and these two magnets are the horseshoe magnet. And see, always the magnetic field lines, magnetic flux, nothing but magnetic field lines, otherwise said to be as a magnetic flux. So lines are moving from north pole to south pole. Okay, north pole to south pole. The lines, these lines are called the magnetic flux or magnetic field lines, moving from north to south. Clear? Now this is the armature. This armature is connected to slip rings. These circles are nothing but a slip rings. What are they called as? Slip ring. Slip ring 1, slip ring 2. That is S1, S2. For this slip rings here now, we are connected to brushes, carbon brushes. B1, B2. These are the carbon brushes. This one is the carbon brushes. Okay, this one is the carbon brushes. Two carbon. And here this is the resistance. This is the wire. Okay, this is the resistance here. Nothing but a load, fan. Here the fan is there here. Now the movement of electricity I'll show you. Okay, how this coil will move here now, how it rotates here. Okay, how it rotates and how the electricity produced. Mechanical energy convert into electric energy. That I'll show you now. Okay, how it will move. So in the beginning, what happened here? The armature will be like this. Okay, this is a beginning shape, the armature, and these fields are going here. This all the fields are going here. Okay, field is magnetic field lines. Magnetic field lines, otherwise called as flux. So imagine these are the magnetic field lines. Okay, these are all the magnetic field lines. So in the beginning, okay, this is a zero, initial state, zero. Okay, all the line comes here, it will be zero here. But slowly what happened, you know, by the force of this magnetic field, this armature slowly start moving then. Okay, when start moving, you know, maybe 2 or 3 will come this side and 4 or 5 will go that side. Clear? Up to 10 will keep, clear, average. So here slowly it moves, you know. So while moving, a time comes, what happened, it will be vertical. Okay, the armature will be vertical, then all the lines can get inside. Clear? All the lines can easily get inside. This is a quarter. Okay, 1/4. Okay, when the armature move 1/4 like this, here at that time it is a vertical position, then completely clear. 0 to 10 maximum here now, maximum magnetic fields are going here. Once again, what happened, it moves. Okay, once again the lines will slowly, what happened, 3 or 4 will be, then again 0. Okay, from 0 once again it will move here now. Okay, once again all vertical here. So it makes one round then. 1/4, 2/4, 3/4, 1. So totally one round then. Totally one round. Where it is moving here now? To backward direction, to the backward. Like this is moving. It depends upon Fleming's right hand rule. Fleming's right hand rule. Okay, this armature will move back like this. Okay, so what the Fleming's right hand rule shows here now? Okay, what the names he has given to the Fleming's here now? Thumb, index finger, middle finger. Thumb, index finger and middle finger. Thumb, what it represent here now? Force. Okay, force. And what the index finger represent here now? Current. Okay, and what the middle finger indicate here, represent here now? Magnetic flux. Now see the magnetic flux, magnetic lines, where it is going here now? Okay, according to you, lines are going from north to south. So keep the magnetic force like this. Flux. This is the magnetic flux. Now where the force here now? Force should be back. Force should be back, and the current will be going up. Clear? Magnetic field line. Clear? Are you understanding here? Magnetic field line. Okay, current is moving up. Force is back. Force is back. Force this side. Okay, current is moving up, and magnetic fields are moving. When the magnetic field moving north to south, current will move perpendicular to it, upward, and the force will be back. Clear? Based on theory, this generator is created. Clear? Understood, you know? So when the force giving the back side here, definitely the armature will move like this, backward. It move backs. Okay, not this side. This side it will. When the force give on this, you know, force is back, isn't it? So it moves. And where the current is moving, you know, upward direction, where the magnetic lines are going, okay, to the north pole to south pole. Clear? So imagine this one, how the current is moving from A to B. Okay, when the force is going back, the current is moving like this from A to B here. Okay, from A to B, okay, this is the flow of current. Okay, from A to B, from B to C, from C to D. See this arrow mark, how it is moving here. C to D, from D to directly come to the slip 2 ring. It do not touches here. This ring, this wire directly touches the slip 2. It will not touch the slip 1. Okay, so construction is like that. So directly the current slowly moves to the slip 2 here now. Clear? From slip 2 to B2 now. Now from here it rotates. Okay, in the slip ring, and then with the brush 2. This is the brush 2. Clear? This is the brush 2. From the brush 2, it enters into the load resistance. Okay, load is nothing but a fan we kept here. So from here once again it is moving up to the B1, B2 to B1 now. Fan, then fan to the here, fan to the B1. Clear? Fan to the B1, then B1 to S1. Okay, B1, from B1 here it enters into S1. From the S1 it enters into the armature. Clear? Once again armature. So from the down the current is moving upward. In the first phase the current is moving from down to upwards. See the arrow mark I have shown here. Clear? I think you understood. Once again I'll tell you how the current is moving here. When the armature is moving, what I told, right hand rule here, Fleming's right hand rule here, force backside. Okay, current upside. Okay, and the magnetic field lines are this side, north to south. Clear? Force this side. According to this lines, you check it out. These lines are nothing but magnetic lines. Current, force. Clear? Force is back. Okay, force is going back here. Magnetic field lines going here. Current is up. Same thing we are showing here. So when the current goes up, this is the direction: A to B, B to C, C to D, from D to directly S2. Okay, directly coming to the S2. Here it rotates and comes to B2. From B2, it comes to the load. From the load, it enters into B1. From B1, the next slip ring 1. From slip ring 1 to directly enter into the armature. Here one round is completed. Clear? One round is completed. See, it like this. When rotation happen here, one round is completed. When one round is completed, first half is completed, the current is here. Now the second half now. This is the first half here now. Now the second half. Second half, what happened? The brushes will be like that only. But changing this position will be there. Clear? Changing of position. Next diagram I'll show you. Okay. See here. This is the next one. Second half. This one. In the second half, same thing. North pole, south pole here. Okay. The current. See the current here now. This S1. See here S1. See the current. Always S1 connections. Okay. From A to B. AB connection to slip 1. Here also when it turn here, then also A and B. Okay. Both B and A and B. Connection will be S1 only. Okay, connection will not change here. Okay, S1, slip 1 connection will be as it is like that. Slip 2 connections also will be like the C and D connection is S2. Here also S2. Clear? But the position you see, okay, S1 here in the beginning it was this side. Okay, it was here. Okay, now in the position 2, it is here now. Because of current movement of this armature. Movement of this armature in the slip rings. Okay, so in the second position it is here. Now see how the current moves here now. In the second phase. It starts from the D and C. Starting from D and C to C and B, C to B, and then B to A, then A to directly slip ring 1. Okay, it touches here now, slip ring 1 here. Clear? Then once it touches slip ring here, it rotates here in the slip ring. Then with the brush 1, S1 to B1, brush 1, then come to the load. Load is nothing but fan here now. From the fan B2, from the B2 the slip ring 2. Okay, it rotates here now. From the S2 directly enter into the armature. Okay, it is coming from upward direction to the downward in the second phase, because both are in perpendicular directions. Both the currents are perpendicular direction here. One is moving up, second is coming down. Clear? In the first phase, the current moving from downward to upward direction. In the second, from upward to downward. Both are alternate here now. That is the reason this AC generator given the name as a alternating current generator. Clear? Hope understood. You can frame this answer. Okay, clear. Otherwise I'll give the answer also. Okay, I'll attach the answer with this video. Clear? Thank you. Next is about the DC generator. What is DC generator means? It is nothing but direct current generator. So why it is called direct current generator, I'll tell you. Okay, I'll explain you why it is called as direct current generator. Clear? So this AC or DC generator convert the mechanical energy into electrical energy, and both the AC and DC generators works on the principle of electromagnetic induction. Okay, electromagnetic induction. Based on this, both the generator will work. And this was perfectly explained by the Faraday. Okay, he has given one law to it, Faraday's law. Okay, I think everybody knows about the Faraday's law. Clear? Anyway, in DC generator here, commutators will be there. This is called commutator. Requirements are there. You have to prepare just like in AC. We have written some requirements. Okay, like that here also we need some requirements. Same. 2 horseshoe magnets we have to take, curved surface. Clear? One armature is there. This is the armature, label it as A, B, C, D. Clear? And then these are 2 split rings, S1, S2, and these are the 2 carbon brushes, B1, B2. This is the wire. Okay, wire is connected to resistance. What we are keeping resistance here, bulb or fan, anything we can keep here. Clear? So how the current passes here in AC alternate current, because the current is moving alternately in perpendicular, isn't it? First half it is from down to up, and the second half from up to down. Okay, the movement of current, okay, flow of current is like that in AC generators, isn't it? So we named as alternative current generator. But here there is not like that. There is no any alternate current moving in, directly moving. Okay, see the current is moving from B to A. Okay, from A to S1. Okay, S1 slip ring here, from here S1 to B1, rubber carbon brushes here, from here to wire, through the wire reaches the resistance, nothing but a fan or the bulb, whatever the electrical appliances you can keep here. Then from bulb to here, it moves along with the wire, come to the B2, from B2 S2 ring here, okay, from the S2 it enters into the armature, DC, then CB, then continuous. Same one rotation only will be there, simple one, same one rotation here. Clear? Only in one rotation. So that is the reason it is said to be as a direct current generator. The name is given to it as direct current generator. Clear? There is no alternative movement of flow of current here. Okay, only in one direction the current will move. Clear? So these points also can write here. Okay, after half rotation, okay, the slip rings, which is called as the commutators. The slip rings S1, S2 is called as the commutators. Okay, after the half rotation, this S2 slip ring will come this side and S1 will go this side. Clear? This also will change here after rotation. Clear? I'll show you. Diagram also see here. In the second half, the S1, okay, S1 is here actually, isn't it? This S1 what happen after rotation, it slowly come this side. Clear? If you see the diagram, you can understand it's still clear. Practical diagram. See here. This is the motor, AC one. Clear? So it rotates like this here. Here it will be. It rotates like this. Clear? It rotates like this. Clear? So when it rotates here now, in the beginning it was S1, S2. Okay. Then the second position see S2, S1. Clear? The rings will be changing here now. Okay. The slip rings will be changing here, but brush remains same. B1, B2, B1, B2. Okay. This continuous flow of current will be there only in one direction. Only in one direction. So this generator is called as the direct current generator. Clear? Hope understood. I'll send the answer also, don't worry. Along with the video, I'll give the answer. And this is the diagrams of AC generator and DC generator. Clear? This is the AC generator. Already you're seeing this pump, I think. Clear? And this is the DC. Okay, DC generator, this one. We put the diagrams here. Okay. This one is the armature. Here also the armature is there. Here 2 slip rings are there separately. Here also slip rings are there, but S1, S2 commutator, both communicate each other here now. Okay, to pass the electricity, whatever the mechanical energy converting into electric energy, it will be passed here. Clear? So there's a differences are there. Small differences are there between. If the question comes, what are the difference between AC generator and DC generator? So these are the some 5-6 differences are there. Clear? Both are work. Okay, both the devices, a mechanical device that converts mechanical energy into an electrical power. Here also the mechanical device that converts mechanical energy into direct electrical power. Here direct, here alternate. Okay, remember that one. Little bit difference. The electric current reverse the direction periodically, isn't it? In the first direction, how it is moving. In AC, how it is moving, upward, down to up, isn't it? And the next, in AC1, what we told you, see, in AC1, in AC generator, what we have shown, the flow of current will be from downward direction to upward direction. Okay, this is the first half. Second half here, from upward direction to downward direction. Clear? This is understood, alternate here. That's the reason the name is given as alternate current generator, isn't it? So these some differences are there. The next one does not have the commutators. Here you can't find any commutators here in AC. Okay, in AC you don't have the commutator here, but whereas here it have the commutator here. Clear? Then used in small motors and home appliances. Here used in power large electric motors. Clear? The different. Then produce a high voltage with varying amplitude. Amplitude will be different in this here, but produce low voltage but constant amplitude. Amplitude will be constant here. This is the major differences between AC and DC. Okay, 5-mark question. Okay, along with the diagram, if you write it, you'll get the perfect marks. Full marks you'll get it. Clear? Hope you have understood this both the topic. Okay, I'll send the answer also along with this video. Clear? If you want, you can frame the answer after listening the explanation, or I'll send the answer also. Clear? Thank you. Here I'll show you the graph of AC generator and DC generator. This was also important for 2 marks question. They'll give draw the graph of EMF of AC and DC. EMF, electromotive force. Okay, so that graph I'll show you. AC generator. What is AC generator here? What is AC means? What is AC generator here indicate? Alternative current generator. Clear? For this graph, initial will be always 0. Clear? Initial will be 0. Then here you have to show the EMF, electromotive force. Clear? Now show from the starting here. No? Okay, here this is the time also you can show here. Okay, now from 0 to maximum. Initial will be always maximum. Only in one of the differences I told amplitude. Remember what is amplitude means here? Okay, write it. What is amplitude means? Okay, what is amplitude? A distance between the resting position. This is a resting position 0. Okay, and the maximum displacement. Okay, of the wave is said to be as an amplitude. Okay, so in the AC, what we told here, from 0 to maximum it is moving, maximum up to 10. Count it as a 10. It's a maximum here now. After that, once again come down to the 0. Okay, here 0 again. Okay, from here alternate, isn't it? Alternative. So it is coming from here also. From once again maximum here. Okay, from maximum to once again 0. Clear? Once again is going to maximum here now. Clear? Maximum here. This is the maximum rotation. Okay, after that once again coming down here. Because of this alternate moving, okay, it is called alternative current generator. Clear? This is a movement here now. Clear? When it is like this, it is 0. Initial will be 0. Initial is 0 here. So when the waves are moving here, electromagnetic pulse, it is a 0. Initial is 0. So but when it is rotating, okay, when the amplitude change, when it is moving here now, so slowly 1, 2, 3, 4, a time comes, okay, all lines enters, magnetic lines, okay, maximum, this is called maximum, 0, initial, 0 to maximum, 0 to maximum, 0 to maximum, 0 to maximum, from maximum to 1 second it becomes 0, slowly comes back to the 0, from 0 to 1 second maximum, clear? So this is the graph of alternate current generator. This is the AC. This is the graph here. Next one, DC one. DC graph. Okay. Same thing here also can write y-axis, x-axis. Okay. Then initial will be 0 here also. Initial is 0. Now it is 0 to maximum rotation. Maximum is the maximum. Then comes down. Here there is a no alternate. Clear? So from 0, 1 second it moves to maximum. Then 1 second comes down. Okay. 1 second from here to move to maximum. Clear? 1 second comes down. So here only one rotation. Okay, clear? There is no alternate current here. Okay, current is not flowing in alternate direction, perpendicular direction here. Current is moving only in one direction. So the graph is like this. This one, this is the maximum. These are the maximum. Clear? This is the maximum. Here it is moving alternately, isn't it? So down also you can show the graph. So this carries 2 marks. Clear? Draw the diagram. Okay, graph here showing the EMF. Okay, electromotive force of AC and DC. The question will be like that. Okay, amplitude means understood what I told on amplitude in one of the diagram I showed you. See here in this diagram I have shown you. Please see the last point. Produce high voltage with a varying amplitude. That is AC. Here in DC, produce low voltage constant in amplitude. What is amplitude means here? The distance between the resting one to the maximum here, zero. Maximum zero movement. That is said to be as an amplitude. Clear?